This is the 5th video in the stoichiometry unit series. It is going to discuss mass-to-mass conversions. By the end of this video, you will be able to use fact-to-label method to convert between the mass of one compound and the mass of a different compound. In order to make this time effective, you want to have in front of you your periodic table, your calculator, a pencil, and your notes or capture sheet. And as always, please feel free to stop the video, try out a problem on your own first, and then see the answer, or simply stop and rewind when you think something might be a little bit confusing or you need clarification. Now in the lab setting, and we've discussed this before, you're not going to be able to count out the moles of a compound. The atoms and molecules are simply too small to do this, and the number is very large, even if you could see them. So as a result, we usually deal in mass. So we usually use the mass of one compound to calculate the mass of some other compound. Now this is going to be a multi-step problem, and it's going to use all the steps we've done in the past. Those steps were using molar mass to go between grams to moles, or moles to grams, and then using the balanced chemical equation and the mole ratio you can get from the balanced chemical equation to find out moles to moles. Let's go ahead and get started. We have the same balanced chemical equation we had in the last video, and in this one, a student fully reacts 3.25 grams of chlorine gas. How many grams of sodium chloride will the student make? So in other words, we have 3.25 grams of chlorine, and we want to find out how many grams of sodium chloride. Well, what kind of facts do we know, or what kind of conversion factors do we already know about this? Well, for one thing, we know a mole ratio between these two. We know that 1 mole of chlorine will react to give us 2 moles of sodium chloride. What else do we know? Using our periodic table, we can take a look at the molar mass of chlorine and the molar mass of sodium and determine the molar mass of chlorine, Cl2, and sodium, NaCl. So by calculating it up, we have 70.9 grams of chlorine is equal to 1 mole of chlorine. And same thing for sodium chloride. Add them up, 58.44 grams of sodium chloride will give you 1 mole of sodium chloride. Now, just to make that a little bit easier to see, let me pull this out and put it right there. That's our list of various conversion factors we might want to use in our problem. And it never hurts to brainstorm these in advance. If you have more than you need, that's fine. If you find that something is missing, go back and try it. Now, when you get ready to start the problem, you always begin with the given. So 3.25 grams of chlorine. Notice that was given in the problem versus what we figured out on our own. Now, any stoichiometry problem, whatever that unit is, goes down to the next square. So I'm going to put grams of chlorine down there. And I'm going to go up and on my list of conversion factors that I brainstormed and think, what do I know about grams of chlorine? Well, I know 70.9 grams of chlorine is 1 mole. So the 70.9 grams is going to go down the bottom where the grams are. And the rest of that conversion factor, 1 mole of chlorine, will go on the top. Now at this point in time, you take a look and you say, is moles of chlorine what I want to know? Because right now I can cancel out my grams of chlorine. And the answer is no, I don't want moles of chlorine. I want to try to find out grams of sodium chloride. So I need to continue. Since I don't like this unit, I want to cancel it out. So that unit is going to go on the bottom of the next square. So moles of chlorine. And I'm going to go up to my conversion factors and see what else do I know about moles of chlorine. Well, I don't want to use 70.9 grams of chlorine equals 1 mole, because that's just going to make me go backwards. But I do know that 1 mole of chlorine gives me 2 moles of sodium chloride. I have this ratio for my balanced chemical equation. So 1 mole of chlorine Then the rest of the conversion factor goes on the top. 2 moles sodium chloride. Now I want to stop and I want to see, do I have any units that can cancel? And the answer is yes. Moles of chlorine and moles of chlorine cancels, which means my answer, if I stopped right now, would be a moles of sodium chloride. Is that what I want to have unit-wise? Well, it's closer. I want grams of sodium chloride. So the sodium chloride part is good, but the grams is what I need. Since I'm not done, I'm going to have to get rid of this unit and bring it down to the next square. So moles, sodium chloride. Then I go up to my conversion factors and I look. What do I know about moles of sodium chloride? And what I know is that 1 mole of sodium chloride, so 1 goes with the mole, is 58.44 grams of sodium chloride. The rest of that goes on the top. So 58.44 grams of sodium chloride. Now I want to see what I can cancel. Well, moles of sodium chloride is the same on the top and the bottom. That cancels. And my answer, if I stop now, would be in grams of sodium chloride. And I want grams of sodium chloride, so this is going to be it. So now I want to remember, how do I do my problem? Well, 3.25 times by 1 times by 2 times by 58.44 is 379.86. On the bottom, I can multiply across the bottom. 70.9 times 1 times 1, so 70.9. Then I want to do top divided by the bottom, which gives me an answer of 5.36 grams sodium chloride. And that is my final answer. Now let's review these steps that we did. Sometimes people will put the steps that you do in stoichiometry into a graphic organizer, which they call a mole map. This is our mole map. Now you can see on the mole map, you can go from mass to moles using the molar mass. You just have to use the right molar mass. If you have compound A, use molar mass A. Then you can go from moles of A to moles of B, which means moles of one kind of compound to moles of something new, using the balanced chemical equation. Those are the coefficients. Then you can go from moles of B to mass of B, compound B, as long as you're using the molar mass of compound B. So we have 1, 2, 3 steps that we can use. Let's try this on the next problem. On this problem we have how many grams of chlorine, so I'm looking for chlorine, how many grams of chlorine are required to make 45 grams of sodium chloride. So 45 grams of this. Let's take a look at our conversion, or our mole map. We're going to go from sodium chloride, grams of sodium chloride, so right here this is going to be sodium chloride, all the way to grams of chlorine. So we're going to go all the way to grams, mass is grams, of chlorine, which means we're going to have to use the molar mass of chlorine, and here from NaCl to NaCl, we're going to use the molar mass of NaCl. So let's get started. Now, just a quick little reminder, we do have some conversion factors we have from the last step, so I'm going to put them down there so we can refer to them. And we always start with a given. So, 45 grams of sodium chloride. Now, without even having to look up here, I know grams of sodium chloride has to go on the bottom, because what's on the top goes to the bottom. And I'm doing grams to moles. See how I'm going from grams to moles, so moles goes on the top. And to go from grams to moles, I'm using the molar mass. But also take a look down here, grams of sodium chloride. What do I know about it? Well, 58.44 grams equals 1 mole. So 58.44 grams equals 1 mole. Now, that's not going to get me done because that's going to give me moles of sodium chloride, and I want grams of chlorine, so moles of sodium chloride goes to the bottom of the next square. And I am now doing moles to moles. Moles is something new. So I'm going to go to moles of the chlorine. using my balanced equation, which means that sodium chloride is a 2 and moles of chlorine is 1. And this, of course, matches up what we have down here. But I don't want moles of chlorine for an answer either. So moles of chlorine goes on the bottom of the next square. And I'm doing moles, 2 grams. So grams goes on the top. So taking a look, I want to use a molar mass of chlorine, which is what I had down here, so 70.90 grams per 1 mole. So 1 goes on the bottom. Now grams of NaCl cancels because they're exactly the same on the top and the bottom. Mole of NaCl cancels exactly the same on the top and the bottom. And moles of chlorine cancels exactly the same on the top and the bottom. To get my answer, 45 times 1 times 1 times 70.9, which is 3190.5. And on the bottom, 58.44 times 2 times 1, which is 116.88. Then I'm going to do the top number divided by the bottom number, which gives me a grand total of 27 grams of chlorine, and my final answer. Now the mole map doesn't hurt to use, but what's really good is if you remember that the units here goes to the bottom of the next square, then think about all those different conversion factors that you have, and what could be useful, and what's the rest of it to go on the top, and keep following those units until you get to the desired unit at the end. That's the trick. And the reality is, this mole map up here that we have will become very large in the future. So it's really good if you can try to avoid memorizing that and instead looking down here. But it is here for people who are very visual and like to use it.